Good morning, children. We'll continue with the problems. We'll just revise this formula. We have limit extending to 0 of sin x by x is 1. X should be in radians. So, in all these formula, as I said, whatever you have here, the same thing should be here and here, the same expression. In the same way, limit extending to 0 of x power n minus extending to a. Limit extending to a of x to the power n minus a power n by x minus a is n a to the power n minus 1. Limit extending to 0 of a power x minus 1 by x is log a to base e. Limit extending to 0 of e power x minus 1 by x is 1. This is a particular case of this where a is equal to e. When a is equal to e, this becomes log e to base e, which is 1. So like that. And this is the next one. Okay, now we'll continue with the problems. Limit extending to 3 of, so limit extending to 3 of e power x minus e cube by x minus 3. Now when you substitute x as 3, it is e power 3 minus e power 3 by 3 minus 3, 0 by 0 form. So you have to use one of the standard limits. How to do? You can put x minus 3 as equal to some y, or you can also do like this. You can take e power, you can write e power x minus, okay, we'll put x minus 3 is equal to t, and we'll do, instead of taking common, we'll do like this. Put x minus 3 is equal to some y. So this implies x is equal to 3 plus y. Now as x tends to 3, y is equal to what? Y, x is 3. So x minus 3, that is x minus 3 tends to 3 minus 3. So that means x minus 3 is nothing but y. So y tends to 0. So we'll write this as limit y tending to 0 of e to the power xx is 3 plus y minus e cube by y. Okay, we'll use substitution. Okay, limit y tending to 0 of, you can write e cube into e to the power y minus e cube by y. Now take e to the power 3 common. E power 3 into e to the power y minus 1 by y. E power 3 is a constant, so you can write outside. E power 3 into limit y tending to 0 of e to the power y minus 1 by y. This is in the form limit extending to 0 of e power x minus 1 by x. Instead of x, you have y. So its value is 1. So it is equal to e to the power 3 into 1. That is e power 3. That is the answer. Okay, next problem. Next one. Limit extending to 1 of, second problem. Limit extending to 1 of 2x minus 1 into root x minus 1 by 2x square plus x minus 3. Now when you substitute 1 here, this is root 1 minus 1, that is 0. So this is 2 plus 1, 3 minus 3, 0. It is again in the 0 by 0 form. So that means when you are putting x as equal to 1, this is 0. It means what? X minus 1 is a factor of this. So find the factor. So it is equal to limit x tending to 1 of 2x plus 2x minus 1. Yes, 2x minus 1. 2x minus 1 into root x minus 1 by x minus 1 into 2x plus 3. This is the other factor. Now you can think of writing x minus 1 as root x minus 1 into root x plus 1. So you can write like this, or you can rationalize. Okay, we'll rationalize otherwise. Because we have irrational, you may think of rationalizing. Then you rationalize root x minus 1 by x minus 1 into 2x plus 3 into multiply and divide by root x plus 1. Root x plus 1. Okay, you can use that also. When you write like this, then what happens? Root x minus 1 gets cancelled. So you can try that way. If you have understood that, you can try that method. 2x minus 1 into root x minus 1 into root x plus 1. So that is root x whole square minus a minus b into a plus b. A square minus b square. So a minus x minus 1 by x minus 1 into 2x plus 3. So now this x minus 1 gets cancelled. So it is limit x tending to 1 of 2x minus 1 by 2x plus 3. Now you substitute 1 here. Then it is when you are substituting, you should not write this limit here. So you will write 2 into 1 minus 1 by 2 into 1 plus 3. So 2 minus 1 is 1. 1 by 3 plus 2, 5. So 1 by 5 is the answer. So like this you have to do the problems. Okay, next problem. Okay, next problem. Limit x. Okay, we'll do this big problem then. Third problem. It is very lengthy. Limit x tending to a of x sin a minus a sin x by x minus a. So here also we'll use substitution. Put x minus a is equal to put x minus a, or else I'll write here. Put x minus a is equal to some y. Then it implies that x is equal to a plus y. Now as x tends to a, x is tending to a. So that implies that x tends to a implies that here you have x minus a. So take minus a, add minus a on both sides. Tends to a minus a. That means x minus a is nothing but y. So y tends to 0. X minus a is y. So y tends to 0. Now we'll take this limit. Limit x tending to a of x sin a. We'll take the question. X sin a minus a sin x by x minus a will become limit. Now write everything in terms of y. Y tending to 0. X tends to a becomes y tends to 0. X will write as x. What is x? A plus y. So a plus y into sin a minus a into sin x. Again what is x? A plus y. A plus y by x minus a is again y. So we'll write y. Now split this. This will not split. Here you multiply a sin a. So this is equal to limit y tending to 0 of, I will draw a line here, y tending to 0 of a sin a plus y sin a minus a sin a plus y by y. Now you can see from these two you can take a common. So it is equal to, again it is equal to limit y tending to 0 of, y tending to 0. First we'll write y sin a and then we'll take plus a common. Then it is sin a minus sin a plus y. Sin a minus sin a plus y by y. Now this is in the form sin c minus sin d. We have the formula. Sin c minus sin d is, in trigonometry you have transformations formula. Sin c minus sin d. You have the formula. Sin c minus sin d is equal to 2 cos c plus d by 2 into sin c minus d by 2. This is the formula. So this is in the form sin c minus sin d. So we'll write is equal to, right here, is equal to limit y tending to 0 of y tending to 0 of y sin a plus a into 2 cos c plus d. C is a. Our c here is a. And our d here is a plus y. So c plus d by 2 means when you add, what is it? 2a plus y. C plus d by 2 into sine of c minus d. What is c minus d? A minus y. That is minus y. So it is minus y by 2. Minus y by 2. Now you also know sine of minus x. Sine of minus x is minus sine x. So sine of minus y by 2 is minus sine y by 2. Whole thing by y. Whole thing by y. Now what you do is divide this separately by y and this separately by y. And write limit also separately. So limit y tending to 0 of y sine a by y plus 2a. We'll write this as 2a cos 2a plus y by 2. 2a plus y by 2 into this is minus into minus sine y by 2 minus sine y by 2 by y. Now write the limit separately for these two. So it becomes limit y gets cancelled here. So limit y tending to 0 of sine a plus limit y tending to 0 of, instead of plus we should write minus here because we have minus sign here. So we'll write minus 2a we can write outside actually. Okay, we'll write 2a cos 2a plus y by 2 into sine of y by 2 by y. Now here it is a constant. There is no y to substitute. So this limit value is just sine a. Sine a minus this is 2a limit y tending to 0 of 2a cos 2a plus y by 2. For this when I substitute 0, this is not becoming 0. So we'll write the limit for this separately and then we'll write sine y by 2 by y like this. We'll write this y under this so that we can again split this limit and write this limit for this separately and for this separately, because we know that limit of f of x into g of x is limit of f of x into limit of g of x. So it is equal to sine a minus limit y tending to 0 of 2a cos 2a plus y by 2 into limit y by 2, y tends to 0 means y by 2 also tends to 0. So we'll reduce this to the standard form. Okay, first we have y by 2 here, y by 2. So here also we should have y by 2 and y by 2 here. So we'll multiply and divide by 2 here. And here also we'll write 2y tending to 0 so that this becomes, this is in the standard form. So the limit is sine a minus, when you substitute y as 0, this is 2a cos 2a by 2 into this limit is 1 into 1 by 2. This limit is all equal to, this limit is 1 because it is in the form limit x tending to 0 of sine x by x. So again these two will get cancelled. This is cos a. Next again these two also will get cancelled. So it is equal to sine a minus a cos a. This is the answer. This problem is very important and very simple also. So put x minus a as equal to y. Then write everything in terms of y. And then you will have a common. Take it and use trigonometry formula sin c minus sin d. So 2 cos c plus d by 2 and all. Now split. Separately you divide by y because these are two terms. So limit of f of x plus limit of g of x like that. So here y got cancelled and here you write in the standard form. Simplify. Okay. Okay. Next problem. Okay. Next problem is again similar to this. This is fourth problem. Okay, we'll do the fourth problem. Limit x tending to 0 of cos ax minus cos bx by x square. Again, if you substitute 0, cos 0 is 1. 1 minus 1, 0. 0 by 0 form. So again, we have to use transformations. Cos c minus cos d. Limit x tending to 0 of, what is cos c minus cos d? Minus 2 sine c plus d by 2. Minus 2 sine c plus d by 2. So you have the formula like this. Cos c minus cos d is equal to minus 2 sine c plus d by 2 into sine of c minus d by 2. This is the formula in trigonometry. So into sine of c. What is our c here? C is ax and our d is bx. Okay, c minus d. Ax minus bx by 2. Now again by x square. By x square. Now when you see, you can take in the angle, you can take x common. So limit x tending to 0 of minus 2 sine a plus b by 2 into x into sine of a minus b by 2 into x. Now then by x square is there. Now to reduce it to the standard form like this, sine theta by theta or sine x by x form, we'll write one x separately for this and one another x separately for this. This is x square. X square can be written as x into x. So one x will write under this sign and another x under this sign. Now this should be written in the standard form. So in the place of x you have this whole thing. A plus b by 2 is missing. So multiply and divide by a plus b by 2. We'll write minus 2 outside and then limit x tending to 0 of sine of a plus b by 2 into x by a plus b by 2 into this x will write. You are dividing by a plus b by 2. So multiply by a plus b by 2. So that it becomes it will be in the standard form of sine theta by theta. This also will change. Now we'll write this into sine of a minus b by 2 into x. This x is already there. So we'll multiply and divide by a minus b by 2 into a minus b by 2. Now we'll write the limits separately for both. So this is minus 2 into limit of sine of a plus b by 2 into x by a plus b by 2 into x into a plus b by 2. And then here as x tends to 0, when you multiply on both sides by a plus b by 2, then you will get a plus b by 2 into x also tends to 0. So now this is in the form limit theta tending to 0 of sine theta by theta. This limit will be equal to 1. This is constant, we can write outside. Now in the same way we'll write limit for this separately. So limit sine of a minus b by 2 into x by a minus b by 2 into x into a minus b by 2. So here also we'll write a minus b by 2 into x tending to 0. So when you multiply on both sides by a minus b by 2, a minus b by 2 into x tends to 0 into a minus b by 2, that is 0. So like that. Now you can write the limits. So minus 2 into this limit, this whole thing is equal to 1. This limit is equal to 1 into a minus a plus b by 2. This limit is 1 into a plus b by 2. Again into this limit is again equal to 1. So 1 into a minus b by 2. So you can cancel 1, 2 and then a plus b into a minus b. A plus b, I'll continue here. A plus b into a minus, so it is equal to minus 2 into a square minus b square by 2 got cancelled. So it is minus, only minus A plus B into A minus B is A square minus B square. So minus 1 into A square minus B square by 2. So this I can write as B square minus A square by 2. So this is your answer. So like this we do. So it is just the trigonometry formula, cos C minus cos D formula, but you must reduce it to the standard form like this. Multiply and divide by A plus B by 2. Here the expressions look lengthy, but it is easy to write the factors. Okay, now next problem. Next, it is fifth problem. Okay, fifth problem. This is again very important. These problems, what all we are doing today, are very, very important. Limit x tending to 0 of sine of pi cos square x. Sine of pi cos square x by x square. So this is the problem. So all this we completed. Now here what you should do is, when you again substitute 0, this becomes cos 0. Cos 0 is 1. Cos square 0 means 1. Sin pi. Sin 180 is 0. 0 by 0 form. So you have to simplify. So what will you do? You will write here the point that you have to remember is, it is very important, very simple also. If you cannot remember this point, you cannot do the problem. Write cos square x as 1 minus sin square x. This point you have to remember. So writing cos square x as 1 minus sin square x. This point, if you can remember, you can easily proceed and complete the problem. So it is sin of, multiply by pi. Pi minus pi sin square x by x square. Now you know sin 180 minus theta, sin pi minus theta. What is sin pi minus theta? Sin pi minus theta, it is in second quadrant. In second quadrant, sin is positive. So we know that sin of pi minus theta is equal to sin theta only. Sin remains sin because it is pi. So sin pi minus theta is sin theta only. So limit x tending to 0 of sin of theta. What is our theta here? Pi sin square x by x square. Now we must reduce it to the standard form. It is in the form sin theta by something. So this theta we should have here. The same thing we should have here. So what we'll do is, we'll multiply and divide by that expression, sin of pi sin square theta by x square is there. So we'll multiply and divide by pi sin square x by pi sin square x. Pi sin square x. Now as x tends to 0, implies you multiply sin x. Sin x also tends to 0. Sin x tends to sin 0. Sin 0 is 0 only. So that means sin x tends to 0. So sin square x tends to 0. Sin square, squaring on both sides. So see 0. So when you multiply by pi on both sides, that also tends to 0. So what we'll do now is, we'll write this here and this x square there. So it is limit x tending to 0 of sin of pi sin square x, sin of pi sin square x by pi sin square x into pi sin square x by x square. Now we'll write the limit separate. This is like limit of f of x into g of x. So limit of f of x into limit of g of x. So we'll write the limit separately. So it is limit is equal to limit x tending to 0 of sin of pi sin square x by sin of pi sin square x by pi sin square x into limit x tending to 0 of pi into sin square x by x square. Now we'll write both in the standard form. This is already there, sin theta by theta. This will change. X tends to 0, so pi sin square x tends to 0. So we'll write is equal to limit pi sin square x tending to 0, pi sin square x tending to 0 of sine of pi sine square x by pi sine square x into this pi will write outside, pi into limit of x tending to 0 of sine x by x whole square, will write sine x by x whole square. So now we know that limit of sine x by x is 1. So I can put brackets here and write whole square. So this limit is 1. So that is not necessary. So we'll write this as 1 into pi into 1, because limit of, I'll write theta. In general, theta, sine theta by theta is equal to 1. This is our theta like that. So the answer is pi. So like this, we do the problem. So here this point you have to remember. Writing cos square x as 1 minus sine square x and then splitting. This is in the form sine 180 minus theta, that is sine theta. Then again multiplying, dividing like this. Okay. Now we'll do the next problem. Okay, sixth problem. Okay, and sixth problem. Limit extending to 0 of 1 minus cos 2 mx. 1 minus cos 2 mx by sine square of nx. So here we have the formula, limit extending to 0 of 1 minus cos 2 theta. 1 minus cos 2 theta is 2 sine square theta. This is the formula in trigonometry. So this will write as 2 sine square mx. So our theta here is theta, 2 theta is 2 mx. So theta is like that. So by sine square of nx. So now what we do is we'll write limit x tending to 0 of 2 into sine square of mx is there, no? So we should multiply and divide by mx whole square into mx whole square, so that it is in the standard form. It is reduced to the standard form. By, in the same way for denominator, sine square of nx is there. So multiply and divide by nx whole square. Nx whole square. Now you can see this is equal to limit x tending to 0 of 2 into sine mx by mx. Sine mx by mx whole square we write into m square x square by sine nx by nx whole square into n square x square. Now we are not writing the limit separately. X square gets cancelled. So 2 m square n square will write outside. We'll write 2 m square n square outside is equal to 2 m square by n square outside, and then we'll write the limit x tending to 0 of sine mx by mx whole square, and here we can write mx tending to 0, because as x tends to 0, when you multiply by m, it also tends to 0. Similarly, nx tends to 0 of sine nx by nx whole square. So now it is in the standard form, and you can write the answer as 2 m square by n square into, this is 1 square by 1 square. So it is equal to 2 m square by n square. Now you can take down the homework. You can solve these 5 problems. So here it is limit extending to a of tan x minus a by x square minus a square. So like we solved some problems, so we'll put x minus a as equal to y. So limit as x tends to a, y tends to 0. So this becomes limit of y tending to 0 of tan y by x minus a into x plus a. You have x minus a into x plus a. X minus a is y and x plus a x is y plus 2a. So it becomes y into y plus 2a. And then you write tan y as sin y by cos y. Sin y by cos y. And then y plus 2a like this. Okay, limit y tending to 0 of. Okay. Now sin y by y limit is 1. and cos y is, you write the limit for this separately, and you can try split. Okay, here we solve, now we solve similar problem, multiply and divide by root x plus 2, rationalize, and here to reduce it to the standard form, multiply and divide by 5, then this is 1, this limit is 1, limit 5x tending to 0. So write like that and then try, you'll get the answer as 5. Okay, next the problem is this by x, and here also we solve similar problem just now. Write 1 minus cos x as 2 sin square x by 2, multiply and divide by x by 2 like that. And 1 minus cos mx is 2 sin square mx by 2, 2 cos square nx by 2. So multiply and divide by m square n square mx by 2 whole square, and you can simplify. You can try these problems. Okay, now we'll continue with the problems in the next period.